Welcome to the channel. My last video covering Alaska Airlines Flight 1282 was flagged by YouTube for deceptive practices or spam. Now, the URL is not spam because if you copy and paste that link, it takes you right to the site. And if it's deceptive because MSN is putting out deceptive information because all I did was read from the article. Having said that, I went ahead and took this opportunity to take that video, which was an hour and a half long, and split it up into three parts. The first part covers the NTSB. The second part covers the FAA, DOJ, and the FBI. The third part covers Boeing. Now, the second part is where the offending URL was listed and the article was, so I removed that from the second part, so you won't see that. But as far as I can tell, the full video is still online, so if you want to watch the video in full, you can go there to watch it. Other than that, let's go ahead and look at part one, which covers the NTSB. Let's go ahead and look at the NTSB. So like I said, first, we're going to look at the this video showing how the door is supposed to operate. I can get it to open. So we see that it's showing the upper bolts, lower bolts. This is the lower hinge point. This is the upper guide and roller. And you'll notice these bolts actually act as latches. So a regular door would have a latch that would open and close it, but these bolts actually act as the latch so that the door cannot move. So now you have a basic understanding of how that's supposed to work. So let's go and look at the couple of images. We'll go ahead and get those out of the way. So here's the outside of the door. I guess I have the other image, but you can see it here. The inside of the fuselage, what it looked like after the door blew out and it landed. So let's go to the briefing, the press briefing that they gave on 1/8/24, and we'll look at a couple of those short videos.
Our systems group focused on the cabin pressure control system on the aircraft. This is the auto pressurization light that illuminated that we have gotten a lot of questions on. This system is designed as a triple redundant system with one primary cabin pressure controller. It's a computer system. There is a secondary cabin pressure controller, that's a secondary computer system. And then there's a manual controller. So there are, it's a triple redundant system. That means that if the primary controller fails, the flight crew switches to the secondary controller. If that fails, they can switch to manual. Any one of these systems is fully capable of maintaining safe cabin pressurization. In fact, if either one of the computer systems is inoperative, the FAA allows the operator to continue flying the aircraft. We have verified from the maintenance logs that the redundant system operated as designed on December 7th, January 3rd, and January 4th. Going into the alt mode, not needing to go into the manual mode. At this time, we have no indications whatsoever that this correlated in any way to the expulsion of the door plug and the rapid decompression.
So let's go to this next video talking about ETOPS.
With respect to the ETOPS restriction, Alaska Airlines reported to the NTSB that their internal policy is to restrict aircraft with multiple maintenance write-ups for certain aircraft systems from flying ETOPS flights for a period of time. That's not required by the regulation. That is an extra step that Alaska Airlines put in place. Now, ETOPS stands for Extended Twin Engine Operations. What that means is that ETOPS permits twin engine airplanes to operate over a route that contains a point further than 3 hours flying time, 3 hours for this aircraft, from the nearest airport. And the restriction was put in place per Alaska as an extra step to ensure safety and to allow them to conduct maintenance.
Now, I've heard it reported on a couple of sites that Boeing or the FAA, I don't remember who they said, but had restricted the aircraft. And she just clarified that it was Alaska Airlines that said, we're restricting it for ETOPS. They took their own steps in restricting it because of this issue. And she said this plane is ETOPS rated at 3 hours, which is 180 minutes. There are different ETOPS ratings. We're going to look at the ETOPS video here in a second. But this one apparently had a 3 hour or 180 minute ETOPS rating. Let's go ahead and look at the ETOPS video that I put together, cobbled together, so you could understand what ETOPS means.
The U.S. Code of Federal Regulations, 14 CFR Part 121, regulates ETOPS operations. ETOPS stands for Extended Operations. The ETOPS area for twin turbine engine-powered aircraft is when the aircraft is beyond 60 minutes from an adequate airport, using one engine inoperative cruise speed under standard conditions in still air, also known as drift down. Flights that operate beyond 60 minutes from an alternate airport require ETOPS authorization. To explain the concept, let's consider the following example. Assume your airline wants to fly from A to C, New York JFK to Madrid, Spain. There is one adequate alternate airfield, B, within range, and that is Tercera Island, Lajes. The 60-minute rule is indicated by the red lines, which show the maximum range the aircraft can be from an alternate airport at any time. As a result, the flight is not permissible under the 60-minute rule. However, if a 120-minute ETOPS authorization is received, as indicated by the green lines, the flight may proceed to its destination following the route AXC. Based on the 120-minute area of operation, flight from New York to Madrid is possible with only a small deviation from the direct route as originally planned. ETOPS authority was established to allow twin-engine aircraft to fly between the U.S. and Europe. There are a number of ETOPS authorities available based on your operational needs. For example, there are ETOPS authorities for 75, 90, 120, 180, 240, and beyond 240 minutes. At this point, there is an ETOPS authority available to accommodate almost any city pairing in the world. Typically, the 120-minute ETOPS authority is obtained to allow twin-engine aircraft to fly between the U.S. and Europe. However, the 120-minute ETOPS authority would not allow twin-engine aircraft to fly between the U.S. mainland and Hawaii. As a result, 180-minute ETOPS authority is required for twin-engine aircraft to reach Hawaii from the mainland. For a route to be legal under 120-minute ETOPS authority, It must lie entirely within circles representing 120 minutes flying time from an adequate airport. For a route to be legal under 180-minute ETOPS authority, it must lie entirely within circles representing 180 minutes flying time from an adequate airport. This concludes the ETOPS lesson.
So there are several ETOPS ratings that can get. Now, this doesn't by any means describe what has to go into getting an ETOPS rating. I mean, there's equipment, airports, fire and rescue. I mean, there's a lot of things that go into it and what they have to do. So even an aircraft with a lower ETOPS rating, they may have to retrofit it and upgrade it so that it gets a higher ETOPS fitting. And I mean, it's just all cost analysis based on the airline and what they do. If they're flying, if they need an ETOPS route, they'll have to have an airplane that can make that ETOPS route. So let's look at the preliminary report that they put out. We're going to go through this a bit. Let's start at the top. So this is the preliminary report for N704AL, which is the 1282 Alaska Airlines flight. Go ahead and January 5th, 2004, about 17 minutes flight. The Alaska 1282 returned to Portland International Airport after the left mid-exit door plug departed the airplane, leading to rapid decompression. It landed safely without further incident. All occupants, 2 flight crews, and all deplaned at the gate. So we're going to look at some figures. So this is where I got some of the photos. So these are better pictures, so you can just see what's going on. So here's the inside and the outside of it. So the photos of the location of the missing mid-exit door plug. We're not going to look at everything here because some of it is just what the flight crew went through, exactly what the flight data recorder said and everything showed what happened and everything. So we're going to skip over that and just go to some more pertinent information. Now there is a flight data recorder and there's a cockpit voice recorder, although the cockpit voice recorder, there's a little disturbing information when it comes to that. So let's look at this. So the CVR and the FDR were removed from the airplane and brought to the NTSB's vehicle recorder laboratory in Washington, D.C. for download of the data. The accident airplane was required to be equipped with a cockpit voice recorder that retained at minimum, the last 2 hours of audio information, including flight crew communications and other sound inside the cockpit. A CVR starts recording when the aircraft is powered on and will continue to record until the aircraft is powered down or the CVR is deactivated, either by a loss of electrical power after a major event or by manually deactivating the CVR circuit breaker after a less severe event. So 2 hours, that's all you get. So the CVR was downloaded successfully. However, it was determined that the audio from the accident flight had been overwritten. So the CVR circuit breaker had not been manually deactivated after the airplane landed following the accident in time to preserve the accident flight recording. This is a problem. I mean, it should not be in their checklist that they need to manually deactivate this if it's not going to deactivate itself. So then it goes into what the flight data recorder recorded. We don't need to go over all that. The operator information and airplane information, how long the plane has been in service. So we get to the mid-exit door description. The airplane was equipped with a mid-exit door plug option, which Alaska Airlines has selected based on its desired seating configuration. Benefits afforded by the plug include more passenger comfort, lower density of passengers, reduced weight, full-size passenger window, a structural component that does not have the complexity of a door with its associated parts. So this is the location of the left and right mid-exit door structure. These are how it would be depending on which configuration you're in. So here's a door that's activated. Here's a deactivated door. And here's the plug. So the MED plug with a standard window, each were located 26th row and left side's plane. So here's the accident. The accident MED plug was manufactured by Spirit AeroSystems Malaysia on March 24th, 2023. So that's where it was made. And it was received at Spirit AeroSystems Wichita on May 10th, 2023. The MED plug was then installed and rigged on the fuselage. Spirit AeroSystems fuselage line 8789 before it was shipped to Boeing on August 20th, 2023. The fuselage arrived at Boeing's Renton, Washington facility on August 31st, 2023. So it was installed and rigged by Spirit at this Wichita facility and then was shipped to Boeing Renton. So the MED plug is primarily constructed of aluminum, installed in the fuselage by means of 2 upper guide fittings and 2 lower hinge fittings. We saw those in the animation. The 2 upper guide fittings are located on the upper sides of the plug. So the guide is on the plug. The roller or the guide pin is on the frame of the plane. And the upper guide rollers that are fixed to the upper sides of the fuselage opening. 2 lower hinge fittings are fixed to the lower section of the plug and engage with the 2 lower hinge fittings that are attached to the bottom of the fuselage opening at the lower. So let's look at figures 4, 5, and 6. So here's 4. So this is the area where the upper guide and pin are, and these are the lower hinge fittings at the bottom of the plug. So AA is here. So this is the rod and the hinge fitting, and the bolt that latches this in place so that it doesn't move is right here, supposed to be installed here. And this is the guide and the roller. So the guide is on the door itself, and this roller is attached to the fuselage. So it goes up in here, and there's a hole here where this bolt goes through, which acts as a latch to keep this roller from coming back down. So these 2 bolts stop the door from translating. So they act as a latch. Once the plug is in place, it is secured from moving vertically by a total of 4 bolts. There is a bolt installed through each upper guide fitting and each lower hinge guide fitting. Once these bolts are installed, they are secured using castle nuts and cotter pins. Outward motion of the plug is prevented by 12 stop fittings, 6 along each forward and aft edge installed on the fuselage door frame. The door plug is only intended to be open for maintenance and inspection, which requires removing the vertical arrestor bolts and upper guide track bolts. The strap assemblies below the second stop pad from the top restrict the plug from opening further. So they have cable straps that actually let the door go out without actually taking it off, because they're going to still be attached at the lower hinge fittings. So here's the cable. So the door actually is hinged down here, and it just translates out so they can do any type of maintenance or inspection they need to do. The NTSB's investigation team conducted a post-accident examination of the aircraft structure, flight deck, cabin interior, cabin safety systems, and pressurization system. So pressurization, we're not going to talk about that. We know what happens when you get a big hole in the fuselage. You lose all cabin pressure. So the left MED plug was recovered in the backyard of a private residence. Luckily, no one on the ground was hurt. The recovered plug and associated hardware was shipped to the NTSB's materials laboratory for further examination. So here's what they've got. And you can see they are missing the spring and the sleeve right here that goes up and down where the bolt hole is. And there's a hole in this, and there's a hole in this. And when they line up, you put a bolt through it, it doesn't let it go up anymore. The two vertical movement arrestor bolts, two upper guide track bolts, forward lower hinge guide fitting, and forward lift assist spring were missing and have not been recovered. See Figure 5, for example. So these are the stops. This is one of the 12 stops, 6 on each side. These, when the door is in place, this part will be down here, preventing this door from pushing outward. So contact was noted on the lower sides of the 12 stop pins and fittings on the MED plug. Corresponding contact damage was noted on 12 stop pads and fittings attached to the fuselage. Overall, the damage was consistent with the MED plug translating upward, outboard, and aft during the separation. Figure 9 shows damage features at the upper forward location and is representative of the other stop locations. So here's the damage. Witness mark matching between upper forward MED plug stop fitting and stop pad fitting as received in the middle lap. Both upper guide fittings installed on the forward and aft sides of the MED plug respectively were fractured vertically through the inboard wall of the track. Examination reveals features consistent with overstress and fracture and no evidence of pre-existing cracks or damage. The outboard upper guide track bolts were intact and exhibited no deformation. Figure 10 shows the aft upper guide fitting. The forward upper guide fitting was similar. So you see, this is actually where the bolt would go through, but when it tore away, it ripped this part of the guide right out of that. So the fractured upper guide fitting, arrows point to the fractured and deformed piece of the guide fitting's inboard wall. The rectangle indicates where the upper guide track bolt would be installed. The paint in the upper guide track bolt bores were intact and showed no evidence of heavy contact damage. Figure 11 shows a representative hole bore. There were some light circular witness marks around the hole bores consistent with the presence of a washer at some time. So this is one of the holes that the bolt goes through, and you can see there's no wear whatsoever, as if there were ever a bolt in there in use. Now there is a slight bit of discoloration here that you can see where at some point there may have been a washer on there, and I would surmise that the bolt was in place when it was sent from the Spirit AeroSystems plant to the Boeing plant, and it was when they opened the door for maintenance, that's when they were not reinstalled. So the aft lower hinge guide fitting manufactured from the MED plug during the event remained attached to the aft hinge fitting. The forward lower hinge guide fitting fractured from the MED plug and separated from the forward hinge fitting. The forward hinge fitting shaft was bent about 0.4 with corresponding contact damage. So this is just getting too much in the weeds for what we got to do here. So the aft hinge fitting after symbol showing that the shaft was bent. So this is the roller pin. The attachment flange on the lower aft hinge guide fitting was fractured at the two upper attach hole locations, and the bolts remained installed in the MED plug. The two lower attached bolts were fractured. All consistent with ductile stress. So you can see the damage here that came about from where it was ripped out of the plane. So let's go to the manufacturing records and human performance. The manufacturing records group traveled to Boeing's Renton, Washington facility to review manufacturing records for the accident airplane. According to records, the accident fuselage arrived at Boeing's facility by rail in August. During the manufacturing process, any defects or discrepancies were found. If they were found, a non-conformance report or an NCR or disposition required an NCR were generated. So it was delivered in August. In September, records show that the NCR was created, noting 5 damaged rivets on the edge frame forward of the MED plug. These are the locations here. Due to this damage, the plug had to be opened up to perform maintenance. To open the plug, the 2 vertical movement arrestor bolts and 2 upper guide track bolts had to be removed. Apparently, there was some damage to the or some issue with the seal also. Records show the rivets were replaced per engineering requirements on non-conformance order, completed on September 19th by Spirit AeroSystems. So Spirit AeroSystems opened the door and fixed the rivets. They're the ones that did the maintenance and built the thing, so they're the ones that are going to have to fix it. And from what I can tell, it looks like Spirit was having several issues, so they actually had to have some employees at the Boeing Renton facility full time. So they didn't just come down there to fix this problem. They apparently, from what my understanding is, they have some Spirit AeroSystems personnel that are in Renton full time. And if you look at the photo documentation here, obtained from Boeing shows evidence of the left-hand MED plug closed with no retention hardware bolts in the 3 visible locations. The aft upper guide track is covered with such can't be seen. So you can look at the image and we'll be able to see it out. So this image was attached to a text message between Boeing team members on September 19th, 2023, around 1839 local. These Boeing personnel were discussing interior restoration after the rivet work was completed during the second shift operations that day. So if you look here, it's hard to see from here, but you can tell from here and from here that there is no bolt installed. It's pretty much buttoned up. They just have to remove the insulation back down and put the outer coverings on. So the investigation determined that the manufacturing documents were used to authorize the opening and closing of the left MED plug during the rivet rework. So also there seems to be a disconnect between the maintenance and how the maintenance is performed. So there's another guy online that I'll put a link to in the description that has a pretty good description of how things actually work there. But Boeing has its own reporting system and Spirit has its own reporting system, and they do not talk to each other. So opening of the door, if you take the door off, the plug off, then there are installation buyback requirements. But just opening the plug does not have closing the plug buyback requirements, which to me is just insane. If you're going to remove hardware that keeps the plug in place, then it should be a automatic buyback or QA inspection item. So the group reviewed applicable application installation retrofit documents, received a presentation on AAR's quality assurance and safety management system processes. The group also witnessed a Wi-Fi. So they went to an Oklahoma facility where work was done on the aircraft. And they determined at this time that there was no other work that affected that door whatsoever. They didn't open it. They didn't close it. They didn't do anything to it. What the work they had to do had nothing to do with that door. So as a precaution, Alaska Airlines grounded its fleet of 737-9 airplanes to inspect the MED plug soon after the event. Their inspections began Saturday morning, January 6, 2024. In addition, the FAA issued an emergency airworthiness directive on January 6, requiring all operators to conduct specific inspections before returning the airplanes to service. January 21st, the FAA published the safety alert for operators that have had the same MED plug as the accident airplane, but on different model of airplane. The SAFO is for Boeing 737-900ER airplanes and recommends operators inspect as soon as possible the 4 locations where the retaining hardware secures the door to the airframe. Boeing issued multiple operator messages. The most recent, dated January 25th, contains revised instructions for inspecting the 737-9 airplanes that have MED plugs. The investigation is ongoing. So that's the NTSB's investigation so far. Hopefully, I'll be able to link on the screen somewhere part 2 and part 3 so that you can watch those. If you like this video, make sure to like, subscribe, and hit the notification bell. Thanks for watching. Peace out.